what I want to attempt to do in this video is figure out what the sine of 7 pi over 12 is without using a calculator. And so let's just visualize 7 pi over 12 on the unit circle. So one side of the angle is going along the positive x-axis. And then let's see, if we go straight up, that's pi over 2, which is the same thing as 6 pi over 12. So then we essentially just have another pi over 12 to get right over there. This is the angle that we're talking about. That is 7 pi over 12 radians. And the sine of it, by the unit circle definition of sine, it's the y-coordinate of where this ray intersects the unit circle. So this is a unit circle, has radius 1. Where it intersects the y-coordinate is the sine. So another way to think about it, it's the length of this line right over here. And I encourage you to pause the video right now and try to think about it on your own. See if you can use your powers of trigonometry to figure out what sine of 7 pi over 12 is, or essentially the length of this magenta line. So I'm assuming you've given a go at it. And if you're like me, your first temptation might have been just to focus on this triangle right over here that I kind of drew for you. So the triangle looks like this. It looks like this, where that's what you're trying to figure out. This length right over here, sine of 7 pi over 12. We know the length of the hypotenuse is 1. It's a radius of the unit circle. It's a right triangle right over there. And we also know this angle right over here, which is this angle right over here. This gets us 6 pi over 12, and then we have another pi over 12. So we know that that is pi over 12, not pi over 16. We know that this angle right over here is pi over 12. And so given this information, we can figure out this, or we can at least relate this side to these other sides using a trig function. Relative to this angle, this is the adjacent side. And so the cosine of pi over 12 is going to be this magenta side over 1, or you could just say it's equal to this magenta side. So you could say this is cosine of pi over 12. So we just figured out that sine of 7 pi over 12 is the same thing as cosine of pi over 12. But that still doesn't help me. I don't know offhand what the cosine of pi over 12 radians is without using a calculator. So let's, instead of thinking about it this way, let's see if we can compose this angle, or if we can decompose it into some angles for which we do know the sine and cosine. And what angles are those? Well, those are the angles in special right triangles. So, for example, we are very familiar with 30, 60, 90 triangles. 30, 60, 90 triangles look something like this. This is my best attempt at hand drawing it. If they have, so instead of writing the 30-degree side, I'll write, since we're thinking in radians, I'll write that as pi over 6 radians. The 60-degree side, I'm going to write that as pi over 3 radians. And of course, this is the right angle. And if the hypotenuse here is 1, then the side opposite the 30-degree side, or the pi over 6 radian side, is going to be half the hypotenuse, which in this case is 1/2. And then the other side that's opposite the 60-degree side, or the pi over 3 radian side, is going to be square root of 3 times the shorter side. So it's going to be square root of 3 over 2. And so we've used these types of triangles in the past to figure out the sine or cosine of 30 or 60, or in this case, pi over 6 or pi over 3. So this, we know about pi over 6 and pi over 3. We also know about 45, 45, 90 triangles. We know that they're isosceles right triangles. They look like this. My best attempt at drawing it. That one actually doesn't look that isosceles, so let me make it a little bit more. So, I don't know, that looks closer to being an isosceles right triangle. And we know if the length of the hypotenuse is 1, and this comes straight out of Pythagorean theorem, then the length of each of the other two sides are going to be square root of 2 over 2 times the hypotenuse, which in this case is just square root of 2 over 2. Instead of describing these as 45-degree angles, we know that's the same thing as pi over 4 radians. And so if you give me pi over 6, pi over 3, pi over 4, I can use these triangles either using the classic definition, SOHCAHTOA definitions, or I could stick them on the unit circle here to use the unit circle definition of trig functions to figure out what the sine, cosine, or tangent of these angles are. So can I decompose 7 pi over 12 into some combination of pi over 6s, pi over 3s, or pi over 4s? Well, to think about that, let me rewrite pi over 6, pi over 3, and pi over 4 with a denominator over 12. So let me write that. So pi over 6 is equal to 2 pi over 12. Pi over 3 is equal to 4 pi over 12. And pi over 4 is equal to 3 pi over 12. So let's see, 2 plus 4 is not 7, 2 plus 3 is not 7, but 4 plus 3 is 7. So I could use this and this. 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. So I could rewrite this. This is the same thing as sine of 3 pi over 12, 3 pi over 12 plus 4 pi over 12, which of course is the same thing. Sine of pi over 4. I'll do this in another color. Sine of pi over 4 plus, let me do this, plus pi over 3. Plus pi over 3. And now we can use our angle addition formula for sine in order to write this as the sum of products of cosines and sines of these angles. So let's actually do that. So this right over here is going to be equal to, this is going to be equal to the sine of pi over 4 times the cosine of pi over 3 times the cosine of pi over 3 plus the other way around. Cosine of pi over 4, cosine of pi over 4 times the sine of pi over 3, sine of pi over 3. So now we just have to figure out these things, and I've already set up the triangles to do it. What is sine of pi over 4? Sine of pi over 4. Well, let's think about, this is pi over 4 right over here. Sine is opposite over hypotenuse. Well, it's just going to be square root of 2 over 2. So this is square root of 2 over 2. Square root of 2 over 2. What is cosine of pi over 3? Well, this is a pi over 3 radian angle right over here. Cosine is adjacent over hypotenuse. So this is going to be, it's adjacent over hypotenuse. So this is going to be 1/2. What is cosine of pi over 4? We'll go back to pi over 4. So it's adjacent over hypotenuse. It's square root of 2 over 2. It is also square root of 2 over 2. Square root of 2 over 2. And what's sine of pi over 3? Well, sine is opposite over hypotenuse. So it's square root of 3 over 2 over 1. Square root of 3 over 2 divided by 1, which is square root of 3 over 2. And so now we just have to simplify all of this business. So this is going to be equal to, the sum of this, or the product, I should say, is just square root of 2 over 4, and then plus the product of these. Let's see, we could write that as square root of 6 over 4. Square root of 6 over 4. Or we could just rewrite this whole thing as, and we deserve a little bit of a drum roll at this point. This is equivalent to, let me scroll over to the right a little bit. This is equivalent to square root of 2 plus square root of 6 plus square root of 6. All of that over 4. That's what sine of 7 pi over 12 is, or cosine of pi over 12, what that is equal to.